So we are going to do the commutative property, which is where we can switch what we're multiplying. Like if you were just doing a number, or what numbers, 4 times 5 is 20, well 5 times 4 is 20. And you're going to see that that doesn't work out the same for matrices, okay? So we're going to take P times Q. So those dimensions, the dimensions of P are 3 by 2. The dimensions of Q are 2 by 3. Okay, so this shows that I can multiply them together, and my solution is going to be a 3 by 3 matrix. Okay, and it has P listed first, Q listed second, so we're taking the rows from P, the columns, whoops, I can't spell, columns from Q. All right, so if you need to make little notes like that, I mean, you can, you don't have to. I'm just showing that to keep it straight here. All right, so if I start my matrix, I want to make sure I have room here. Come over here. Okay, so I'm in the position of the first row. Whoa, sorry. First row, so I'm taking the first row from the first, multiplying it by the first column to be in that first position here. So I have 8 times something plus -7 times something, and that first column was 9 and 6. Okay, I'm going to go ahead and move down to the second row, -2 and 4. I'm still in that first column, so I'm still using 9 and 6. Okay, let's do the third row. So 0 and 3. Still in the first column, so I'm using that first column of 9 and 6. So you kind of see the pattern here, at least with the columns. You see that the column has to go straight down. I just changed those numbers of the row to determine what row I'm in. Okay. Up above in the 2 by 2 matrix, that pattern is there. It's not as easy to see. These 3 by 3s is a lot easier to see. All right, so let's move over and deal with the second column here. Okay, well, I'm going to start in the first row and use the second column. Okay, so I get 8 times something plus a -7 times something, and that something is -3 and -1. Actually, I can leave that circled since I'll use it a lot. Okay. Move down to the next row. -2 and 4. And I'm using that column of -3 and -1. Okay, move down to the third row. 0 and 3. And that column is -3, -1. And you see the pattern of the rows. This 8, -7, 8, -7, okay? That continues throughout, all the way across. Things that change are the columns. Whereas going down, the columns don't change. The rows are what changes. All right, so now let's do the third row. Okay? I'm sorry, I said third row. Third column. We'll eventually do the third row as well, but we're going to start with that top row. So 8, -7, and that column is 2 and -5. Move down the next row is -2 and 4. That column is 2 and -5. Okay, third row is 0 and 3. And that column is 2 and -5. Okay, so I did every row and column. As you can see, I will have a 3 by 3 matrix. Okay. You can use your calculator to find these terms if you want. Just enter in that whole thing in your calculator in the order it's in. Okay, so let's see. 72 plus a -42 would be a 30. Going to the right, we'd have a -24 plus 7 be a negative 17. 16 plus 35 would be 51. Next row, negative 18 plus 24 would be 6. 6 plus a negative 4 would be 2. Negative 4 plus a negative 20 is negative 24. Bottom row, 0 times 9 is 0. And then I have 3 times 8, or I'm sorry, 3 times 6 is 18. I started saying the answer there. Next one's going to be negative 3 and then negative 15. Okay, so there is P times Q. All right, so now let's come over here and look at Q times P. So Q is a 2 by 3 matrix. P is a 3 by 2 matrix. Those are the same, so I can multiply it, but my answer is going to be a 2 by 2. So you see how it doesn't work out to be the same matrix as the answer? Okay. All right, so again, I'm going to take the rows. The Q came first, so I'm taking the rows from Q, then it was P, and I take the columns. It's always rows, then columns. It's how we name the dimensions, and it's how we do the multiplication, okay? All right, so we're going to start with the first row and then the first column, okay? So first row is 9, going to multiply by something, plus a negative 3 multiplied by something, plus a 2. Whoops, I didn't want to do that, okay? Now this column is positive 8, negative 2, and 0. Okay, so I'm going to go down now and do the second row. So 6, negative 1, negative 5, and I'm going to multiply that by the column over here. So 8, negative 2, and 0. Oops, it switched. Move over to the next column. Okay, I'm going to be in the first row, second column. So 9, negative 3, and 2. I like to write out the whole row first and then fill in the column, then trying to jump back and forth between the matrices. I find that's where a lot of errors then start occurring because you forget what you're pulling from. Okay, so that column is negative 7, 4, 3. Okay, we're going to move down to the next row. So second row here, 6, negative 1, negative 5. That second column is negative 7, 4, and 3. So this will give me my two terms. Love it when I have these zeros. They add up to 0, so that's easy. So 72 plus 6 is 78. Negative 63, negative 12, and 6 is negative 69. Let's see, 48, 2 is 50. Negative 42, negative 4, and negative 15 is negative 61. Oops. So notice the matrices aren't the same. So what works when we're just multiplying numbers, like 4 times 5 is 20, 5 times 4 is 20. They're interchangeable. It's not the case with matrices.